Hi everybody, today we're looking at radical functions. Now radical functions in general are actually functions which involve an nth root. So that could be a square root, a cube root, a fourth root, and so on. Now we're just going to focus on square roots. The IB syllabus doesn't actually include any specific mention to radical functions as a particular function that you need to graph, but it does talk about being able to find the domain and range. When it talks about being able to find domain and range, it gives an example as being able to find the domain and range of a square root function, which probably indicates that we should at least highlight these functions. So let's think about what the square root of a means. Well, it means that when we multiply a number by itself, that gives a. So the square root of a is a number when multiplied by itself gives a. For example, if we take the square root of 25, we're asking ourselves what number multiplies by itself to give 25, and the answer is 5. However, it's important to note something about this. You could have said that, well, negative 5 multiplies by itself to give 25, and that's correct. But convention tells us that if we're square rooting a number, it doesn't actually equal the negative. So the square root of 25 is not equal to negative 5. Let's look at some equations that you would have solved last year and how you would have done that to emphasize this point. So if, say, we look at the equation x squared equals 25 here, then when you solve that and took the square root of 25, you had plus or minus out the front. In other words, this plus or minus was external to the square root. In other words, it was outside the square root. It wasn't part of the square root. So what you're saying when you had the plus or minus out here is the answer to the equation x squared equals 25 will either be the positive of the square root of 25 or the negative of the square root of 25. And so then the square root of 25 gives us 5. So the plus or minus isn't part of the answer to the square root of 25. The plus or minus is something we add in because we know that the solution to the equation could be plus or minus. Now, what you didn't do, so this is not what you did, is you didn't say x was equal to the square root of 25 and then say that that's equal to plus or minus 5. So this is not done because minus 5 is not part of the square root of 25. And that's really purely by convention, that if we're saying that we want the square root of a number, we're talking about the positive. If we want to consider the negative, then we have to say specifically that it's a negative square root that we're looking at. Okay, alright, now for rational functions, we saw that x-intercepts occur when y equals 0, y-intercepts occur when x equals 0. First of all, when we have y equals 0, then and probably should say or the actual function equals 0. We're talking about the same thing because remember y coordinates represent function values, and so that's going to require the solving of an equation, and y-intercepts occur when x equals 0, and so that requires substitution of x equals 0 into the equation. Okay, now if we're thinking about the domain, we use the information that the square root of f of x does not equal a real number if f of x is less than 0. In other words, we can't take the square roots of negatives. For example, if we think about the square root of negative 9, well, 3 times 3 is equal to 9, so the square root of negative 9 can't equal 3. And minus 3 times minus 3 also equals positive 9, because two negatives multiply to give us a positive. So the square root of negative 9 is not equal to negative 3. Now negative 3 times positive 3 equals negative 9, but now these are not the same number. So we're not multiplying the same number by itself. And so the square root of negative 9 equals no real solution. Okay, for the range, well, the range uses what we talked about before, that the square root of something has to be greater than or equal to 0. So if we're just talking about the square root and there's no negative in front, we're talking about the positive values. Okay, let's have a look at this function. 2 take the square root of 2x plus 3. First of all, we want to find the x-intercept. So we're going to have to solve 2 take the square root of 2x plus 3 equals 0. Now if I move the 2 to the other side, I get the negative square root of 2x plus 3 is equal to negative 2. And then if I square root both sides, I get 2x plus 3 equals 4. And so 2x equals 1, so x is equal to a half. Now it's always worth double checking answers when you've squared both sides of an equation. So squaring both sides of an equation can produce wrong answers. So it's always important to check your answer that you get. Now I'm pretty sure in this case that we don't have a wrong answer in x equals a half, but I am just going to do a quick check. So my check is to say 2 take the square root of 2 times a half plus 3 is 2 take, now 2 times a half is 1, 1 plus 3 is 4, so that's 2 take 2 equals 0. Okay, alright. Now, so x equals a half is correct, so my x-intercept is a half 0. My y-intercept, well, when x equals 0, I get 2 take the square root of 2 times 0 plus 3, which will be 2 take the square root of 0 plus 3, which will be 2 take the square root of 3. The square root of 3 is approximately 1.7, so this is approximately 0.3. Now the x-intercept I'll write down as 0, 2 take root 3. This answer here is for when I come to graph it. Okay, now the domain of the function. Well, 2x plus 3 has to be greater than or equal to 0. So if I consider this, 2x has to be greater than or equal to minus 3. So x has to be greater than or equal to minus 3 on 2. That's my domain. It simply comes from the fact that 2x plus 3 cannot be negative. Now what about my range? Well, my range, well, the square root of 2x plus 3 has to be greater than or equal to 0. And so then if I'm doing 2 take that, well, it'll be 2 take the square root of 2x take 3 will be greater than or equal to 2 take 0. So 2 take the square root of 2x take 3 has to be greater than or equal to 2. Now, what I've actually done is I've not respected the fact that I'm bringing in this negative here. So I'm going to take this out, and that's a good learning opportunity for everybody. So to get, I really need to think of my function, and I'm going to take all of this out. I need to think of my function as minus root 2x plus 3 plus 2. That's going to help me get it right. So let's start again. The square root of 2x plus 3 has to be greater than or equal to 0. I next look at the fact that I'm multiplying my square root by negative 1. Now when I multiply both sides of my inequality by negative 1, the sign gets reversed. So negative 2x square root of 2x plus 3 will be less than or equal to minus 1 times 0, which is just 0. And so now if I add 2 to both sides, well, that'll be negative 2x plus 3 plus 2 will be less than or equal to 0 plus 2. So it'll be less than or equal to 0. And so my range is that y is less than or equal to 2. Okay, let's draw the function on the axis given. Now, when x equals, well, first of all, let's plot our points. So the x-intercept was a half, which is there. Our y-intercept was approximately 0.3, which is about there. Now, it's probably useful to put a couple more points on. So, first of all, remember we're starting at x equals minus 3 on 2. So we're starting out here. That's where my function is going to start. Now, when x is equal to minus 3 on 2, well, when that happens, 2x plus 3 is 0. And so my function will be just 2 take 0. And so the highest point will be there. And so it will be coming down from there. Now that fits with the range being less than or equal to 2. So that's good. Okay, alright, now perhaps one more point. And we'd like to pick a point when 2x plus 3 actually gives us something that gives us a whole number when we square root it. So if we think about, for example, when x is equal to, well, if it's 1, it's 5. If it's 2, it's 7. If it's 3, if x is 3, 3 times 2 is 6, plus 3 is 9. So that's probably going to be, so we get the square root of 9, which is 3, and 2 take 3 is minus 1. So you're just going to have to do some quick substitutions to work out when your function underneath the square root will give you a squared number, so it's easy to work out. So that's probably enough points. I'll just quickly make a point that when x equals 3, the square root, so we got, I should say that 2 take the square root of 2x take 3 is 2 take the square root of 9 is what we were working out, which is minus 1. Just as a quick identification of where that point came from. Okay, so we've got some points, and because this is draw, we need some good accurate points. And then it's a matter of just drawing the function so it goes through those points. Now, a sketch is different. Okay, a sketch puts all the key points on, and it's a good idea that when you're putting it on the points, just label them. So this is minus 1.52. This is 0, 2 take root 3, which we worked out was 0.3. This is a half 0. And I'll put that above the x-axis because my function will lie below. But I'm not going to find my other point, okay, because I'm only doing a sketch. So a sketch has to include the general right shape, which I've got there, and it also has to include key points, but it doesn't have to be perfect, okay? So you can see that potentially my points aren't exactly in the right position compared to each other, but they're close enough, and I've labelled them, so I've identified to the examiner that I know the key points, and I've got them roughly correct. Okay, alright, so that's the difference between a draw and a sketch, and that's radical functions.